Hi all, welcome to Digital Drilling. Let's update. I hope that new technologies, smart skills and trust are the top priorities for upcoming years expected by the corporate world. Hence, we need to update the topmost technology which are trending all over the world. Okay, in this session we are going to see only about containers, what are containers and what is the benefits of containers, what is containerization, what is the difference between containers and virtual machines. Let us compare it and many. Okay, let us start up with the containers. So the containers are very much important mainly in cloud computing because it highlights the core benefits, and we also going to see the emerging ecosystem related to the technology across Docker, Kubernetes, Istio and native. So Dockers and Kubernetes, I have already posted some videos, so I share you the link below. You can see it. And Istio and native are the different thing. So we will be discussing what are those. So talking about container is a unit of standard with the software that can be packaged up and all its dependencies to the application can run quickly, reliably from one computing environment to another. That's why we are using container. So I can say container is a standard unit of a software for packaging up the code. So containers are packages of software that contain all the necessary elements to run in any environment. Make a note of it, in any environment. In this way, containers virtualize the operating system and run anywhere from the private data center to the public cloud and even on developers' personal laptops. For example, from Gmail to YouTube to search everything at Google runs in a container, right? So everything are in a package based. Okay, so containerization allows our development team to move fast, deploy software efficiency and also appropriate at an unprecedented scale. So we have seen about containerization. Now we can see how to share these containerization, how to use, how to deploy the applications over the containerization. Mainly these containers are used to build, share and run your application on any environment. So in Dockers and Kubernetes we had an idea over it. So now let us have a different point like what are containers. Containers are executable units of software in which application code is packaged along with its libraries and dependencies in common way so that it can be run anywhere, whereas it can run on a desktop and traditional IT or a cloud based. So to do this, containers take an advantage of a form of operating system virtualization in which the future of the operating system, in case it may be a Linux kernel, namely I can take cgroup primitives or namespaces and the leverage to both isolated process as well as it helps to control the amount of CPU, memory as well as the disk that those processes can access to. And these containers appears in the decade ago with the version like FreeBSD, like we also call it as FreeBSD jails and AIX workloads. These containers already came into the picture. So why containers? Containers are small, fast and portable because unlike a virtual machine, containers do not need any guest operating system in every instance and instead simply leverages the future and resources of the operating system. So there are many things we can discuss about containerization. Suppose if you take a Docker container, let us take an example with a Docker container. So Docker container can run on a Docker engine with a standard, lightweight and secure form. If you take a Kubernetes container, yes, you can run it in a Kubernetes field, right? So likewise, if you need an exact definition of a container, let me give you a prescribed definition of a container. Container or lightweight package of your application code together with the dependencies such as specific versions of programming languages, runtime and libraries required to run your software services anywhere in this world. So we have seen like what are containers, right? So then why virtualization? So what is the difference between the virtual machines to the containers? You would have played games, virtual games, right? So these containers are almost similar to that virtual machines. So one better way to understand a container, that we need to know the difference between the traditional virtual machine to the containers. So in traditional virtual machine, what we do, whether it is be on premises in your cloud or a hypervisor, it can leverage the virtual physical hardwares. So each virtual machine then considered a guest in your operating system, a virtual copy of your hardware that the OS requires to run along with the applications and its associated libraries and dependencies. Instead of virtualizing the underlying hardware, containers virtualize the operating system. Typically, you can take a Unix based or Linux based. So each individual containers contains only the applications, and its libraries and dependencies can be taken over there, and the absence of the guest OS, that's why we are using the containers. In virtual machine, definitely you need to have the guest OS. While talking about your containers, you need not to have that OS over it. Okay. So next, what is the main benefits of your containers? So separation of responsibility, I can say. Why? Because containerization provides a clear separation of responsibility, as developers can focus on application logic and dependencies, while the IT team operations can focus on the deployment and management instead of application details such as specific software versions, configurations, etc. Right? So I can say the main benefit of containers are separation of responsibility. Second, workload portability. Yes, guys. So containers can run virtually anywhere, greatly, easily, and we can develop it anywhere and we can deploy it. For example, anywhere in the sense you can develop it with Linux, Windows or Mac operating system, on virtual machines, or on any physical servers, or on the developer machine, or in the data center on premises, and of course in the public too. Okay. So application isolations. So application isolations means like you can virtually can see the CPU, memory storage and network resources at the operating system level, providing the developers with the view of operating system logically isolated with the applications. So there are lot more benefits. So I can say these containers are lightweight. In case of container, shares the machine OS kernel, operating system kernels, and eliminating the needs for full OS instance per application and making the container files small and easy on the resources. And it is portable and platform independent. It improve utilizations. So lot more we can say when talking about the containers. So where these containers are mainly used. So some of the use cases I can say it is mainly used in the applications with modernizing and migrations. For example, one of the most common approaches to the application modernization starts with the containerization, then so that they can migrate to the cloud. Even hybrid and multi-cloud uses this container. DevOps, development plus operation team, uses this container and microservices, or some of the use cases I can say for containerization. So from the beginning I'm telling about containerization. So what do you mean by containerization? So software need to be designed and packaged with different in order to take the advantage of the container, and the process is commonly referred to as the containerization. When containerizing an application, the process includes the packaging of an application with its relevant environment variables, configuration files, libraries, and software dependencies too. And one of the containerized orchestration is Kubernetes. So talking about Kubernetes, as many of the companies began embracing the containers often with the part of modern cloud native architecture, the simplicity of the individual container began with clouding with the complexity of managing hundreds of containers across the distribution. So to address this, the containerized orchestration emerged away from the large volume of the container throughout the life cycle, including provisioning, redundancy, health monitoring, resource allocations, scaling, and so on, I can say. Even these containers are used in Istio, native, and other expanding container ecosystems, guys. So what is then Istio? We have seen about Docker's Kubernetes, right? Then what about the Istio? So this Istio is like as developer leverages the container to build and run on the microservice architecture management concern, go beyond the lifecycle consideration on the individual container and into the way of large number of smaller services offer us to refer as a service mesh. There we can connect it with the related to another one. So this Istio was mainly created to make it easier for the developers to manage and associate challenges with many discoverable traffic monitoring and security purposes. Okay, what is native? So native or like a serverless architecture continue to grow with the popularity as well, particularly within the cloud native community. These natives have a big value and it has the ability to deploy the containerized services on a serverless function. So it's going to be a big deal and it's going to be blooming in the future. So that's it about containers. So still talking about containers, the main usage of the containers. So what is the main use? We have seen benefits, right? Containers uses or mainly offers a logical packaging mechanism in which the application can abstract from the environment in which they actually run. They decouple, allowing you the container based application to be deployed easily and consistently regarding of whether the target environment is a private data center, the public, or even the developer's personal laptop. So these things can be used with agile development, efficient operations, and run anywhere. That's what we are using this types of containers. So you can include the containers with Kubernetes, clouds, and Dockers, and lot more. So that's it. In next session we can see with different technical trends. Thank you guys.